Hey, good day. Welcome to JCSF online tutorial class, online physics tutorial class. So I remain my humble self, JS. So physics, your physics tutorial master. Today, so we want to start with a rectilinear acceleration. In our previous class, we talked about scalars and vectors. So I will try to look into what the scalar quantities and what the vector quantities. So we talk about scalar quantity as the one that has magnitude with no direction, and the vector is the vector quantity as the quantity that has both magnitude and directions. So we try to look into the different examples of scalars and vector. So we talk about example like mass of a body, volume, area, length, energy, speed as an example of scalar quantity. Now, and we talk about momentum, force, displacement, acceleration, velocity as another example of vector quantity. Now, for you to enjoy details about our previous class, you can just help yourself by subscribing to JCSF online tutorial on YouTube, so that you can have access to our online classes. So with that, our previous classes, you can have access to every one of them. So today we start with rectilinear acceleration. So do not forget that when at the beginning we talked about acceleration, so that is the distance for a body to move in a distance. So, but today we want to look into acceleration, rectilinear acceleration. So we talk about some concepts of acceleration. Here now we'll be talking about rectilinear motion, and we'll be talking about translatory motion. So we're talking about rectilinear motion, we're talking about translatory motion, displacement, and we talk about linear motion and their types. We move to velocity. We talk about the average velocity. We talk about instantaneous velocity. We look into speed. So we talk about the Jack Jones. So then we look into velocity time graph. Now, let's start with the class. So we want to talk about rectilinear acceleration, but before we continue with the explanation, so we just firstly have to remind ourselves about what we mean by acceleration. So acceleration is defined as the rate of change of velocity with respect to time. So acceleration is defined as the rate of change of velocity with respect to time. So I've talked about this under our fundamental and derivative quantity and unit. So the rate of change of velocity with respect to time is what we refer to acceleration. Now, when we get back to that, now we talk about the concept of acceleration. The concept of acceleration. Here now we talk about some types of motion. So under the concept of acceleration, remember acceleration is the rate of change of velocity with respect to time. Change of velocity with respect to time. And there's no way we'll be talking about the change of a body or a velocity with respect to time without trying to look into the motion and the form of motion that we bring about the change of velocity with respect to time. Now, for the reason we first talk about the rectilinear motion. So a rectilinear motion is the motion along a straight line. So it's the motion along a straight line. For those of you who have been following our class, we've talked about that. So, and representing them mathematically, we use only one spatial dimension. So that is rectilinear motion, a motion along a straight line. Now, linear motion is the most basic of all motion. So, and you know, according to Newton's law of motion, according to Newton's first law of motion, so object that does not experience any net force, an object that is moving that does not experience any net force, so such kind of object will continue to move in a straight line with a constant velocity until they are subjected to a net force. If they are not subjected to a net force, there is no any way. So the object will experience any, the object will not stop. They will continue to move in a straight line with a constant velocity. So such object will continue to move in a straight line with a constant velocity until when they are subjected to a net force. So now, under everyday circumstances, external forces can cause an object to change the direction of its motion so that its motion cannot be described as linear. So external forces affect the motion of an object, and which can make the object not to move in a linear. An object that is moving on a straight line now may have a net force that may not allow it to go in the same direction again or move into another direction. So it moves to another direction due to what? Due to external force. So that is what can cause the effect of the linear motion under the concept of acceleration. Sometimes we do compare linear motion to general motion like this with like other motion. So I'm still trying to put more light to linear motion before we talk about some time. So we may compare linear motion to general motion. For instance, in general motion now, a particle's position and velocity are described by vector which have a magnitude and direction. So normal motion, in general motion, a particle's position and velocity are described by vector which have a magnitude and direction. So, but in linear motion, the direction of all the vectors describing the system are equal, and which means the object moves along the axis, and do not change direction. Now, what are we trying to explain? Now, generally in motion, a particle position and velocity are described by a vector, which have a magnitude and direction. So if you have a magnitude and direction, maybe this will also come back any other way. But in linear motion, so the direction of all the vectors describing the system, the direction of all the vectors that is describing the system of the motion are equal. So, and this implies that the object moves along the axis. So the object moves along the axis and do not change direction. So they move along the axis and do not change direction. That is in linear motion. But in other motion, so there is an effect because of the vector. So the magnitude and the direction. Two things is going to happen to it. But in linear, so in the same direction. Just like a linear deal with a scalar. So linear motion under here are grouped to two. So we have two types of linear motion. We have two types of linear motion. We have two types of linear motion. We have uniform. We have uniform linear motion. We have uniform linear motion, and we have non-uniform. We have non-uniform linear motion. So we have, those are the two types of linear motion that we have. Now, we have uniform linear motion, we have uniform linear motion. Now, we talk about uniform linear motion now. So, what is uniform linear motion? So, an object is said to undergo uniform linear motion if the rate of change of displacement or velocity is constant. So, no matter how small the time interval may be, linear motion. So, if the rate of change of displacement or velocity is constant, so and no matter how small the time interval may be, so that is uniform linear motion. So you have to underline. So the sentence, no matter how small the time interval, no matter how small the time interval so may be. So no matter of the change of velocity or displacement is constant. So it is uniform linear motion. You have to know that in as much the rate of change of velocity or displacement is constant. So it means it's undergoing uniform linear motion. Now, when we talk about no uniform linear motion, so we talk about uniform linear motion. So before we can say a non-uniform linear motion, so an object is said to undergo uniform linear motion if the rate of change of velocity varies. The opposite of uniform linear motion is the non-uniform linear motion. So this is when the rate of change of velocity varies. When the rate of change of velocity varies, then we refer to it as non-uniform linear motion. So non-uniform linear motion, when the rate of the change of velocity varies. So that is uniform. But so if the rate of change of velocity is constant, so it is uniform linear motion. Now, with that, let's quickly talk about the translatory motion under the concept of acceleration. Translatory motion. We quickly talk about that, then we move to velocity. Translatory motion. Translatory motion. Now we talk about translatory motion. So translatory motion is the motion in which all the particles of the body move through the same distance at the same time. So translatory motion is the type of motion in which all the particles of the body move through the same distance, so at the same time. So all the body, when the particles of the body move through the same distance at the same time, through the same distance at the same time, that is what refers to a translatory. So another translatory motion is also grouped into two. Translatory motion is also grouped into two. So here we have rectilinear motion and we have curvilinear motion. We have rectilinear motion and we have curvilinear motion. So those are the two types of translatory motion. Initially, we talk about linear. So we are dealing with translatory motion now. So which is the type of motion in which all the particles of the body move through the same distance at the same time. Now, And we have two types, which is rectilinear and curvilinear motion. So with this now, the rectilinear motion, so is the type of motion, so in which the particle of the body move through the same distance at the same time on a straight line. So is the rectilinear motion is the type of motion in which the particles of the body move through the same distance at the same time on a straight line. So while the curvilinear motion is the type of motion in which all the particles of the body move through the same distance at the same time, so in the circular form. So in the circular form or in the curved form. So that is rectilinear motion and curvilinear motion. Now, with that, we can quickly talk about velocity. Then we move to average velocity and move to the normal work for the day. Remember, we are dealing with rectilinear acceleration. Velocity. So when we talk about velocity, we're not talking about the average velocity. So we're not talking about average velocity. Now let's talk about velocity now. We've talked about velocity before under the motion, under the fundamental and drive unit. So talk about velocity. And we talk velocity is defined as the rate of change of displacement with respect to time. So the rate of change of displacement with respect to time. This is different from acceleration, which is the rate of change of velocity with respect to time. So acceleration is the rate of change of velocity with respect to time, while velocity is the rate of change of displacement with respect to time. So as velocity is the change of the rate of change of displacement with time. So acceleration is the rate of change of velocity with respect to time. So you need to understand that. So you need to understand that the acceleration deals with the rate of change of velocity, while velocity deals with the rate of change of displacement. And you should not forget that the SI unit of velocity is meter per second, or meter per second. So now that is start to look at the average velocity. So average velocity is different from normal velocity. So we have said that velocity is the rate of change of displacement with respect to time, but average velocity is the ratio of total displacement taking over time interval. So let me try to explain again. The average velocity is the ratio of total displacement as taken over time interval t. What are we talking about? So velocity, average velocity is represented by V, capital V, AV. So, and when I said that the average velocity is the what? The ratio of total displacement. So total displacement S all over, so time interval T. Now, you need to understand this. We are dealing with average velocity now. And so it's the ratio of total displacement. Total displacement is S. Taking over what? Over time interval, which is T. So average velocity will be equal to S all over T. Now, this is equal to S2 minus S1 all over T2 minus T1. Now you need to look into that. Now, we got to the ratio of total displacement to over time interval. Now, S all over T, we got to S2 minus S1 all over T2 minus T1. Where S and T1, so angle S and T1, so is the what? Is the time at which the object was at position. So and T2. Explain clearly. So it's the time at which the object was at position S2. Now we try to look into this with the average velocity. Average velocity is equal to angle S all over angle T, which is the ratio of total displacement, so all over time interval, which is angle T. Now, which is equal to S2 minus S1, S2 minus S1 all over T2 minus T1. Now, where S, angle S, so, and T2 is the time at which the object was at position S1 and T2. So what am I trying to say? So where S, let me just put it this way, so you can get the clear explanation. We are dealing with average velocity now under rectilinear acceleration. Now, this is what I'm trying to say. Let me write out it. Average velocity is equal to total displacement S over time taken T. So this will be equal to S2 minus S1 all over T2 minus T1. Now, this is what I was trying to explain. So now that we know that where displacement S and T1, displacement S and T1, so is the time at which the object was at position S1 and T2. S1 and T2. So is the time at which the object was at position S2. S1 and T2 is when the object is at position S2. Now, what I'm trying to explain here is the displacement and the time T1. So this is the time at which the object was at the position S1 and the T2. When it moves like this, so it will be in position of this and this. And this S1 and T2, so it's also the time at which the object was at position S2. This and this, S1 and T2, is also when the object is at position S2. Why? S1 and T2 is when the object is in the position S and T1. This is the position, and this is the position. This was standing between. So as simple as that, there's no any magic trick. You just say, so average velocity is equal to total displacement all over so time interval, which is equal to S2 minus S1 all over T2 minus T1. We are trying to explain that. So when ST1 is the time at which the object was at position S1, T2. ST1 is when it's on T2. And also S1, T2 is when the object is in position S2. This and this is when the object is in position of S1, T2. And S1, T2 is also when the object is in position S2. So that is that. Now, let's quickly talk about instantaneous velocity. Instantaneous velocity. Instantaneous velocity. Let's quickly talk about that. We talk about speed. Then we talk about the calculation under linear. Now, so the instantaneous velocity can be found by differentiating the displacement with respect to time. So we can find instantaneous velocity just by differentiating the displacement with respect to time. With that, we can find the what? The instantaneous. And this is represented by V is equal to ln all over the time 0, which will give us the displacement, the displacement all over the time under the average velocity. So, and this will be equal to the S all over the T. So, instantaneous velocity. Remember, we said that it can be formed by differentiating the displacement with respect to time. Differentiating the displacement with respect to the what? To the time. On average velocity, so with the we talk about the displacement and the what? And the time. So which is the average velocity is the ratio of total displacement taken over time interval. So, but under instantaneous velocity, we are said to find that we have to differentiate the displacement with respect to what? To time. We will have to differentiate the displacement with respect to time. So, and that is why velocity is going to live all over. So the time and ratio of displacement over ratio of the time interval. So, and this is going to give us the S, the T. So you may not understand those formulas clearly, but when we start with the calculation, so you can get to understand. But whatever, you should try as much as possible to be taking note of this. You should be trying as much as possible to be taking note of that. So now that is instantaneous velocity. That's what you need to know about the instantaneous velocity. Then we can talk about the speed. the speed. So speed is the absolute value of velocity. So speed is the absolute value of velocity. So, and speed is always positive. So speed can never be negative. It is always positive. So it's absolute value of velocity. So, and the unit of speed is meter per second. Now, when we use u as the speed here now, when we use u as the speed, u will not be equal to, remember we said that speed is the absolute value of velocity. U will not be equal to v, which is equal to the s dt. Nobody should get confused. We are trying to put out the formula, to take out the formula and look into it, how they work together. Then we start applying them. Remember where we started from. We started from average velocity, where we said that average velocity, VAV, is equal to displacement all over time, where you go S2 minus S1 over T2 minus T1. So where we said that where T1 is the time at which the object was at position S1, T2. So it's also the time at which the object was in position S2. Now we move from there, we now talk about instantaneous velocity. Where that V lim all over time, and this gives us the displacement all over time, which we arrive at ds dt. What gives us the s dt is the velocity, which is under the velocity, instantaneous velocity. So the velocity under the instantaneous velocity is instantaneous is where we got the ds dt. Now we are dealing with speed now, and I said the speed is the absolute value of velocity. So the speed is the absolute value of velocity. Now, we said that we should assume that u is the speed here now. So that means if u is the speed and speed is the absolute value of velocity, that means u will still be equal to velocity. And our velocity under instantaneous velocity is ds dt. So this is what you need to know. So the magnitude of the velocity is the instantaneous velocity, which is instantaneous speed. So you need to understand that the magnitude of the velocity now is the instantaneous velocity, which is the instantaneous speed. Now, this is our speed, which gives us, which is the same value, absolute value of velocity, the dt. So you have to take note of these two. Take note of these two. So now that is speed. Now, let's talk about acceleration. The time is against us. So let's talk about acceleration. So we've known acceleration as the rate of change of velocity with respect to time. So, and it's also the second derivative of displacement acceleration. Displacement. So it can be found by differentiating position with respect to time to twice or differentiating velocity with respect to time. Once. So we all know the SI unit of velocity as meter per second square. That is the SI unit of the velocity. Now, here we talk about average acceleration. And if we talk about average acceleration, that is acceleration. And if AV, if we take AV as the average acceleration, so if AV is the average acceleration, and we also have velocity, which is equal to V2 minus V1. Now, mathematically, we cannot say that the average velocity and the acceleration, average acceleration velocity, AV, V, OAV. So, average velocity of the time interval, this will be equal to rate of time or velocity all over time. All over time, which is equal to V2 minus V1 all over T2 minus T1. So we are trying to put things together. We are dealing with the acceleration now, average acceleration. So, and we said that if average acceleration and average velocity is equal to V square, V2 minus V1. So, which is the average velocity over the time interval. Then mathematically, we can now have the average acceleration and the velocity as V all over T, which is equal to V2 minus V1 all over T2 minus T1. This under average acceleration velocity. Average acceleration velocity. You have to take note of these two. Average acceleration and velocity. So V all over T equal to V2 minus V1 all over T2 minus T1. Now, that is, you take note of this formula too, under average acceleration and velocity. Now, let's talk about the jack. Do not forget, we are dealing with rectilinear acceleration. Jack. Of acceleration. So jack is the rate of change of acceleration. So and the third derivative of displacement is known as jack. The third derivative, of cubic meter per second. So this is the side of jack. And it's also known